Hey class, it's Mr. Shrum, and I just wanted to go over a few key points in this Methods of Science tutorial. So this tutorial is all about the scientific method and how we use it to investigate. Tutorial warm-up. So it asks you before you go through the tutorial, in your idea, what you currently know, what is the definition of science, and put it in your own words. Don't worry about being right, because it's going to ask you the question afterwards too, and see if your idea has changed at all. And then it asks you to write one question that you think an experiment could find out and help you understand. You can watch this video on your own, but I'll skip it for now. Inquiry. So science is a subject you learn about in school, but everything involves science to some degree. Science is just the study of natural events and processes. So we use that when we cook. We use that when we construct buildings. We use that when we use our phones. And it has a lot of branches. You can study space, planets, moons, chemistry, the way certain substances interact. Life science, I should be on the next page. That studies living organisms, you or me. Hopefully we are alive still, you know. And it also studies between living things and non-living things. But yeah, these are some of the branches of science. And what all of these branches of science, and in any realm of science, they use the scientific method. And this is probably the most important part from this tutorial, this method, right? To reach a conclusion in their area of interest, they follow these steps. And the steps are the same for every scientist. You can watch this video, but you can get the basic gist of it after we complete this tutorial. So here's our first lesson activity. And in the video, a family observes something, and this asks you to identify it and what makes them want to investigate. Part B, it asks you, so with this experiment, what was he trying to answer, Dr. Philip Tierno? So this activity is getting you to understand, you know, why people pursue experiments, like what makes them ask certain questions, and then what are those experiments trying to do? It's just to get your mind thinking. But it started with an observation, and we do this in everyday life. We just observe stuff around us, and that makes us question things. I wonder. It's this curiosity that drives a lot of science. So observations are the first step. And in this example, Mary sees two plants of the same subtype. One's in the sun and one's in the shade. So she observes that the one in the sun is taller than the one in the shade. And this makes her want to do an experiment. Like, is it really the sunlight that's making it taller? Or is it something else, right? Make observations and ask questions. Observations, then questions. That's the scientific method so far. So Mary's question, do plants need sunlight to grow? And this is important to remember that these questions have to be measurable to some degree. We need data and numbers and these hard facts. And we'll get into that later, what makes a valid question. But once you make observations, you ask questions, you are going to come up with a hypothesis. And this is a very scientific word, a very important scientific word. But a hypothesis is you predicting what will happen based on what you have observed. It's like an educated guess before you start experimenting. So you make a prediction for the experiment, and then you perform the experiment. And this is known as testing the hypothesis. And an example of a good experiment is that you control everything but the thing that you are testing. These factors are called variables. So you can only change one thing at a time in an experiment. So for a plant in the sun versus a plant in the shade, everything else would have to be different besides the sun, the sunlight. So the water, the temperature, the type of plant, right? How tall the plant is starting out, that all has to be the same. So you know that the one thing you're investigating is the thing causing change. So Mary hypothesized that the plant growth depends on sunlight. That is her educated prediction. This shows you the steps she went through. And she kept the sun, water, temperature at constant values. And she's just changing the presence of sunlight. And here we go. This is a very important picture. So hopefully you write this down, save it somewhere. But this is a great visual about these steps of the scientific method. Making observations, questions, hypothesis, testing a hypothesis with an experiment, analyze your results, and then you repeat. And if you keep getting the same result, then you can conclude and communicate it with your scientist friends in a journal. But we'll talk about that later. But repeating and retesting is a key part, because sometimes you can get a weird result. But if you repeatedly test it out and you keep getting a weird result, then you can make a conclusion. But if you do one experiment, that's not very strong evidence for testing your hypothesis. You have to do it again and again to draw a conclusion. And so Mary was able to conclude that plants need sunlight to grow. And science is a collection of facts. So scientists prove that these facts or ways of going about things are true by publishing results in journals, scientific journals. And other scientists are able to modify or repeat an experiment so they can better understand the phenomenon. And in this example, Mary tells her class about it. And so they are able to test their hypothesis as well. And the more you test, the stronger your argument and conclusion. becomes. And this just asks you, how could she design another experiment to test this new question? So this brings it back to the warm-up. What exactly is science? And then come up with a question that you think is measurable, that you can design an experiment with. So a hypothesis is a prediction before the experiment is performed. However, once an experiment is completed and repeatedly tested, a scientific theory can be developed. It's an explanation of observations by scientists when they repeatedly conduct experiments. So a theory is like, okay, so we've done this experiment this way, and it keeps happening predictably the same way. Then that becomes a theory where scientists don't necessarily need to test it again, and they can take it for granted. Not take it for granted, but understand that that certain fact is reality to some degree. Like gravity. We know gravity exists. If you drop anything on the earth, it will fall to the ground repeatedly. That keeps happening. So think about that. And as a law, that is a repeated pattern in nature. So actually, well, a law is gravity because it has a predictable pattern in nature. Every time you drop an object, you can predict that it will fall. So before gravity was a scientific law, it was a theory. So scientists hypothesized about gravity. It became a theory after they conducted several experiments. And then, since it's a repeated pattern in nature, it is known as a scientific law, universal fact. No matter where you are on Earth, gravity pulls you towards the center of the Earth. So asking questions, very sciencey, very big part of science. And these questions have to be measurable. So these are measurable. They can deal with numbers. However, these questions deal with opinions, values, things that don't exist outside of our minds, our human consciousness. So is it ethical to pollute the environment? Well, you can't scientifically study if it's ethical or not, but you can study how polluted the environment gets. That is measurable. But the ethical, whether it is right or wrong, is outside the realm of science. And so is determining what's prettier, a dress in this shop or... So it's very subjective. And if it's subjective, you can't test it with science. And this just asks you, all right, can you identify scientific questions and not scientific questions? So if it has pretty, should, right or wrong, chances are it's not scientific. So this goes into reading scientific information. And in science, it's good to be skeptical. So don't automatically assume that someone is telling the truth in science just because they're a scientist, right? Or they have some type of authority. you want to test it yourself or look for further research. Double checking is always great in science. And we'll look into why things can kind of get a little biased. When you're reading data, facts, measurable data, it's important to remember that you have to reduce the bias in any way. Journalists and people writing about science and data may use opinions and try to have a one-sided view of things and not remain objective. So it may not be accurate all the time. When people unfamiliar with science talk about science, they can sometimes make incorrect assumptions and use the wrong words. And that may influence people that are reading these articles, and they may take away the wrong idea. And we'll have an example later. But these are really good questions to ask when you're reading something or watching a video about a certain topic. Is the writer or person in the video using facts and evidence? Are they just talking about their opinion of something, or is it real? Is it a fact? Are they an expert in the field? Chances are, if someone is a scientific expert in the field, they are more familiar with science and talking about science. Does the writer have a bias? And do you know what a bias is? Bias means you have a certain interest in looking at the facts one way. So if you are, well, we'll get into the example later, but if you're in a honey making business and there's a scientific study about honey, you have a bias because you want the study to come out seeing that honey is good for people. So that makes you skewed, and you could tamper with the evidence or use the words in the wrong way. And that is known as bias. Where the opposite of bias is we're trying to be as fair as possible. So yeah, this talks about the healing powers of honey. And then this activity asks you to see, is there any bias? Are they using opinions? Are they using enough evidence and facts to back up what they're saying, or is it more wishy-washy? And then this part asks you, so what part makes you want to double check? Like, is that really true? Are they making claims that maybe they need more evidence to support before they can just say that, you know? And then the last part asks you, what type of data would scientists need to conclude that honey decreases the risk of coughing in all people? So in this article, it's asking you, okay, so can you think of any data that they can use to determine, to design an experiment to conclude that honey decreases the risk of coughing in all people? So I'll let you answer that using your thinking brain, thinking cap, whatever the term is. But this asks you, to write a question that is measurable and that an experiment could answer. Now that we've talked about this. And talking about measurable data, this is how we measure it with tools. So when it comes to weight, scales are great to use. When it comes to length or width, height, anything dealing with that, rulers of some sort are used. And a unit of measurement is a fixed amount of a quantity. So think of an inch, a foot. Those are the same regardless of where it is used. A foot is 12 inches, and that's that. So that's how science can measure certain data. So we have length, weight, volume, time, temperature, and these are the units that they can use. And this is known as a system of units. The US has one set, and the rest of the world, well, most of the rest of the world, uses a different set. I think I prefer the international one. It's just a little easier to think about because everything is based on the power of 10. Where in the US it's kind of weird. Why is there 12 inches in a foot? Why not just make it 10 inches, right? It's just easier to remember. And then there's 3 feet in a yard. Like, why? And then in a mile, it's like 5,000 feet or so. Yeah, so it's just strange to me. Where kilometer is just 1,000 meters, and then 100 centimeters are in a meter, and then 10 millimeters are in 1 centimeter. And so it's just 10, 10, 10. It's really easy to remember. And they're all like that for length, mass, temperature, time. Not time or temperature, sorry. Length and mass are like that. But these are what we use in science to make sure everyone's on the same page. Scientists from the US, scientists from European nations, Asian nations, South American nations, Australia, other North American countries like Canada, Mexico, African nations too. If we're all using the same system, this makes it easier to communicate with each other and to make sure we're getting the same results. And this talks about converting. This is probably the most math you're going to see in the science class. But it's just using ratios. And in this one, it shows you. So 1 centimeter is equal to 10 millimeters. 1 centimeter is equal to 10 millimeters. So the ratio is 10 millimeters to 1 centimeter. And if you have 4 centimeters, you just multiply that by this ratio. Centimeter cancels out with this bottom centimeter, and you get 4 times 10, which is 40 millimeters. Okay? And we'll get into that more later. But converting units will become important. So this just asks you to do a math problem. So you start out with 330 grams, and you're asked to find the difference between 330 grams and 250. So the first step would be to subtract since these are both in grams, and you're left with 80 grams difference. And we know the ratio of 1 gram is equal to 1,000 milligrams. This prefix milli is 1,000th. So that is how we know 1,000 milligrams to 1 gram. And so now we just multiply the ratio. So we have 80 grams times 1,000 milligrams over 1 gram. Gram cancels out with gram. You have 80,000 milligrams, okay? So subtract, find the ratio, multiply the ratio. And that is the steps we are going to use again and again. And this is the summary. This is a summary video, but this picture is the most important takeaway, because this you will use past this class for the rest of your life in some of your jobs. Science affects us all, and this is the most basic, bare bones science there is. You observe the world around you. That gets you asking questions. You make a prediction, design an experiment. You look at those results. You keep doing those experiments. If you get the same results again and again, you can make a conclusion and then communicate the results to other humans. So this is how humans have made progress through the ages. It's being curious, conducting experiments, repeating that, and then sharing with each other what we found. And science can be very collaborative and progressive and fun in some cases, believe it or not. But that is the best takeaway. And that is our first tutorial. So I just wanted to walk you through that. And I hope you found that enjoyable to some degree. But that is our first tutorial, just an intro to science. And yeah, that's it. So I will publish this video and talk to you guys, girls, and pals later. And yeah, okay. This has been Mr. Shrum. See ya.